Hi, everybody. Welcome back. Okay, we are looking at moving into our next lesson, which we'll start at the bottom of page 70. Okay, that goes with our Thursday lesson. Feel free, of course, to look at these videos ahead of time. I'll try to have them recorded as quickly as I can. Our next part will pick up right here at looking at factorials. Here I am. I'm going to share my screen again with you. All right, here we go. So we're looking at picking up where we left off with sharing here. Let me change my color again. Okay, so we're looking at factorials, permutations, and combinations. So this is our next set of homeworks. Now we're going to need our calculator for this. So pull out your calculator. I'm going to be pulling up a graphing calculator here that I'll be using to show you your scientific calculator. If you have that, follow along and try to see if you can find your buttons. Again, if you have trouble finding your buttons that I'm talking about, please Google your calculator to see where your buttons are located. And then practice using your buttons on your calculator and seeing how your calculator wants you to put the information in to get it. Okay, so I'll pull that up as we need it. Let's talk about what we're doing here. Let's look at factorials first. Factorial, here's the definition of it. Factorial is represented as n with the exclamation mark. And the exclamation mark means factorial. What is it saying? We're talking about multiplying numbers that start at one number and work all the way down to 1. So we looked at it in our previous video with some of our examples where we have, say, 5 times 4 times 3 times 2 times 1, or 12 times 11 times 10 times 3, all the way down to 1. So factorial helps us to not have to do all those calculations by hand one at a time. We can use this function in our calculator to help us get to the answer more quicker. Okay, so in your calculator, we're going to be doing some calculating of factorial. In your graphing calculator, we're going to find that button. In your scientific calculator, I have a Casio here in front of me, but in your scientific calculator, factorial is usually in a second function over a button. So you may want to pause the video and try to see if you can find your factorial button. Is usually, if you have a scientific calculator, it is usually in a second function. Some calculators may have it on a face button, but most times it is in the second function, so something over a button. And then you would activate it by pushing your second or your shift key. So take the time to find it now, if you can, and then see what happens there. You can pause the video and come back when you're ready. If you have a graphing calculator, you would go to your math button. So all the keys are, that we're going to be using so far, especially in this next video, is going to be found in your math button. You see here along the top, you'll see PROB for probability. You're going to scroll over, doesn't matter how you do it, scroll over and highlight the probabilities column, and you'll see NPR, NCR, and then your factorial button. So we're going to be using buttons number 2, 3, and 4 right now. So 2 represents your permutation, C represents your combination, and 3 represents your combination, and 4 represents your factorial. And this is the only 3 buttons that you'll be using right here in the probability section. Okay, again, in a scientific calculator, these buttons are located in the second function. That's something over a button in the second function in your calculator. All right, so I'm going to clear this out. Here, they want us to calculate 7 factorial. 7 factorial is represented as 7 times 6 times 5 times 4 times 3 times 2 times 1. And so normally we would just go ahead and put all of this in by hand. But now with this factorial button, we don't have to do that. So in your calculator, you would put in 7, then push math, scroll over to your probabilities button, come down to your factorial button and push enter. And it should look exactly like they have in the problem. Then you would push enter. And it would do the multiplication for us and give us the number 5,040. Right? So 5,040. So factorial helps us to cut off the middleman from us doing everything by hand. We could just go right in there, use our factorial button, and it will calculate it for us. Also, by definition, we have to note that 0 factorial equals 1. Now we know from our multiplication tables that 0 times anything is 0, but not with factorial. So factorial, 0 factorial equals 1. If you want to try, you're not sure, if you ever forget, just put it in your calculator. We know where the button is. We can also use this as practice. 0 factorial, it will tell us that it equals 1. All right? So 0 factorial equals 1. Okay? So now, let's look at permutation and combination. So permutation actually has a formula as well as combination. So some people actually like to use the formula. Some people like to use the button. We have the button, as we see in our calculator, that does the work for us. But then we also have the formula that goes along with it. So I'm going to give us the formula, and then we're going to practice it in our calculators to see what the calculator can do for us. What we have to remember about permutation. So with permutation, remember that order matters with permutation. So here's some things to remember. So note. Okay, number 1, you have no repetition. All right. Now, oh, it's an E. No repetition. And most importantly, the second thing, order matters. Right? So we did some problems in our previous video where order did matter. And remember, we ordered the pictures, and they put the words in there. We want to order these things. That's where this comes in at, those permutations. That's when you know you're doing a permutation. So order matters. That's very important to know. For the formula for permutation, you have NPR. Now let's talk about what N means and what R means. So we have to make note. I'm going to run out of room here, so I'm going to write it up here at the top. So we know that N equals, this is the total number of items we can pick from. All right, the total number of items we can choose from. Then your R represents the number of items we pick, or the rate at which we pick them. So the number of items we pick. So we have our N, the total number that we're talking about. That's in whatever they give us, the total number. And then R is the rate at which we can pick those items. Okay. So with our permutation, our formula, we say NPR, or you could say N perm R. So NPR, the formula is N factorial divided by, in parentheses, N minus R factorial. Okay, so you would take your N and replace it here, find the factorial, divided by your N minus your R, whatever it is, and then take the factorial of that number. And that will give you a permutation. For your combination, here's what's to note. Right? First things first. I can't hardly write with this thing. No repetition. Okay? And secondly, okay, order does not matter. Okay? Order does not matter. It's combination. Permutation, it matters. But combination does not matter. That's going to be the key between the two. You see, that's the only difference. So I need you to make sure when you're reading your problems, you got to pay attention. If you need to order something, then you know you're going to be doing a permutation. If they're not asking for order of any kind, combination, right? Here is the symbol representing combination, NCR, or N combo R, right? So NCR, the formula, N factorial, all over. And it looks similar to our permutation, but it's one difference. Here's the difference. We're going to multiply denominator by R factorial. We're going to still have the same part here, though, right? Times N minus R factorial. So the formulas are similar, except for with combination, we have to actually take in and multiply denominator by that extra R factorial. And once we do this, we do our replacement and plug in, it'll give us the combinations. These things are different, right? You're going to see in just a second what the difference is and how the numbers are different when we put them in our calculators. Now we can, of course, write this in the formulas, but we're going to practice in our calculators. Right now, hopefully you found your buttons. If not, again, make sure you Google it. But in your calculator, now I'll pull up my graphing calculator. They want us to solve for 5 perm 3. So 5p3. So in your calculator, usually you would put in just how you see it. The 5 comes first, then you go and get your permutation button, and then put in your 3. If your calculator wants you to get your permutation button first, and then it has 2 little open squares for you to fill in, then you'll follow that pattern of your calculator. But only you would know what your calculator is doing because you have it. Okay, so here, I'm going to 5, go to my math button, scroll over to probability, come down to permutation, push enter, and then you see how I'm ready to fill in my second part here with 3. And so now it looks exactly like my problem. I'm going to push enter, and my answer is 60. So we have 60 ways, right, that we can order these 5 items, taking them 3 at a time. What happens when we take those same 5 items, but we do combination 3 at a time? Right? So now I want to take 5, it's my math, go into probability, come down to combination, get my button, choose 3, and then entered. Look at the difference. So now we see there's only 10 possible ways, right, to do a combination of these 5 items, choosing 3. So it's a big difference between combination and permutation. So make sure, 1, you recognize if you're doing one or the other. 2, and when you're putting in your calculator, you're choosing the right button. Make sure you're doing it. Now look at these next ones. You see you have 3P5. You cannot choose 5 items from 3. You don't have enough items. Is that logical? No. But what happens? What's your answer? Let's see what the calculator tells us. Now, in our common sense, we should know what we can do and what the answer will be. But let's see. So we have 3. Math. Go over to probability, or go to get your probability button. Push enter, and then 5. Look, 0. It's not possible for you to have 3 items and then you're going to choose 5. You don't have enough. So your answer is going to be 0. What do you think about combination? You have 3 items and you want to choose 5. Should still be 0, right? Still not logical there. Your N always has to be bigger than your R, because you got to choose these things. You got to pick these things from the group. So your group has to be bigger than what you're trying to pick from, the number of items you're picking from. All right, let's go to the next problem. Number 9. All right, it says, suppose we have 6 men, 2 Democrats, 3 Republicans, and 1 independent. We have 8 women, 3 Democrats, 4 Republicans, and 1 independent. How many ways could we pick a female president and a male vice president? So here they're giving us this situation. Here we have 6 men, and they broke them down into different categories here. How many? 6 men. What do we have? We have 2 Democrats, we have 3 Republicans, and 1 independent. Now I'm writing this out because when you start looking at all the words, sometimes they run together and you'll get to looking at the wrong thing and putting the wrong numbers with the wrong stuff. So sometimes it helps to sum up your numbers along with your words, right? Then you have 8 women, and how are they broken down? You have 3 Democrats, 4 Republicans, and 1 independent. All right, so that's what we're looking at. It says, how many ways could we pick a female president and a male vice president? So here's our structure. We need a president and a vice president. So we need 2 lines. We need a president and a vice president. Okay? but we need the president to be female and the vice president to be male. Now, how many females do we have? We have 8. We have 8 choices for president. That could be female. Then we need a male vice president. How many of those do we have? We have 6 males. So we have 6 choices there. Make sense? Right? So now when we multiply this together, 6 times 8 gives us 48 ways that we can have a combination of a female president and a male vice president. Right? Then it says B, line up 4 Republicans. 4 Republicans. There's our structure. We need 4 lines. So we need to line these up. So 1, 2, 3, 4. They need to be Republicans. Well, now, how many Republicans do we have? 3 here and 4 here. 3 plus 4, that's 7, right? So we have a total of 7 Republicans, right? So if we have a total of 7 Republicans, then there's a couple of ways we can look at this. So if we're only going to look at Republicans and we want to line them up. So this first position, we have 7 to choose from. Then here we have, that's right, 6, and then 5, and then 4. But look, it's going in a pattern, isn't it? 7 times 6 times 5 times 4. That looks like going into what? Combination or permutation? What do we think? Does order matter here? Yes, it does. Why? Because we have to line them up. All right? So because we're lining them up, that's permutation. Right? So we can also write this problem as, how many did we have total? 7. This is a permutation because order matters. And how many did we have to choose from? Like, how many did we have total? 4. So 7P4. So we can do our fundamental counting principles, or we could have written it as 7P4. So 7, pick 4. Either way, we're going to get how many? So 7 times 6 times 5 times 4, or putting this in our calculator would give us 840 ways. So we see how we have a choice. So if it's a permutation, we could also write it as a fundamental counting principle. All right, so you have options. So you might see it one way, you might see it another. But lining up people, order matters. Okay, let's try our next one. It says, pick a 5-person committee of 2 Democrats, 2 Republicans, and 1 independent. Now it says pick a 5-person committee. A committee. Does a committee have order? No. All right, so committee. No order. Okay? No order, no repetition. Okay, it doesn't matter here. So what does this mean? A combination. So now we need these different categories. So we have a 5-person committee that consists of Democrats, Republicans, and Independents. So we need a line for Democrats, a line for Republicans, and a line for Independents. So we need 2 Democrats, 2 Republicans, and 1 Independent. We are going to use our combination setup to write our structure. This is how we're choosing. Because now remember, we got a group of these people that we're choosing from. So now we go back up here. All right, so out of the Democrats, how many do we have? We have 5 total. Do you see that? So we have 2 here and 3 here. That's 5 total. But we only need to choose 2. So we have 5 combo 2. So look at the Republicans. How many Republicans do you have total? We have 7. So we have 7 choose or combo. How many we need? Only 2. Do we see what we're doing? With the independents, how many do we have total? We just have 2 independents total. So 2 combo, we only need 1. All right, so here's our structure. In order to create a 5-person committee consisting of 2 Democrats, 2 Republicans, and 1 independent, we need to first draw our structure. We have 1 line for Democrat, 1 line for Republican, 1 line for independent. The first one, we're going to add up all of our Democrats. So we have a total of 5, but we only need to choose 2. So 5 combination 2. Then for Republicans, we have 7 total. So 7 choose 2. Then for our independents, we have total of 2, but we only need to choose 1. So now when we do our calculations in our calculator, we have 5 C2 space over in your calculator. You're going to put all of this in the same, in your calculator, the same at the same time. Make sure you space out of your sub number times. You have 7, go get your button again, C2, again, cursor over, times 2 combo 1, and then enter. And you should get 420 ways. Now, in some of your calculators, you may want to use your parentheses functions for this to make, to do your multiplication. That's fine. Either way should work, but you should try out your calculator to see which one. You may feel comfortable just doing each calculation separately and then go back and multiply. That's fine too, as long as you get the concept. So when we add these, multiply these together, you get 420 ways. Okay. All right, I hope we're getting the pattern and seeing what's happening. All right, here we go. Looking at pick a 4-person committee. Again, we're still doing a committee. Right? Again, no order there, so we know we're talking about a combination still. That is composed of all Republicans. All right. So a 4-person committee that is composed of all Republicans. How many Republicans did we say we had? I believe it was 7, right? But we want to choose 4 of them. So right there we have 7 combo 4. 7 combo 4. So 7. 35 ways we can make up this 4-person committee. All right. E, pick a 4-person committee, again, a 4-person committee, again, that is composed of all independents. So, 4-person committee, all independents. Now watch it now. How many independents did we have? We look back up here, we only have a total of 2. Now what did we say before? When we set this up, you have only a total of 2, and you have to choose 4. Is that possible? No. So you have 0 ways that you can choose this 4-person committee. You only have 2, right? So not possible. Okay. So that concludes our example for number 9. Let's look at 10. How many ways can we arrange the letters in Mississippi to form unique arrangements? So now in this particular next 3 examples, we're looking at how we can arrange letters in a word to form unique arrangements. So let's put a pin in it. So when we're looking at finding unique ways to do something, when we're picking out letters from a word, the key things, how many ways, that's one thing. And then they give you a letter, a word to look at. And you want to first identify, of course, how many letters total are in this word. That's the first thing. So, first, that's your first step. How many letters are in the word they're giving you? Okay. Then, second step, identify the number of repeating letters. So any letters that's repeating, identify what those letters are and how many times they repeat. That's going to be important because then we have to divide that number of letters out so that we don't double, triple, or quadruple count those things, okay? So our structure is going to be dividing the total number of letters in the word divided by the factorial of the number of repeating letters. So the factorial of the total number of letters divided by the factorial of each repeating letter. And then when we calculate it, that's going to tell us how many ways we can have or arrange to form unique arrangements of these letters. So here we go. Let's count. So we have Mississippi. How many letters do we have in the word? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 total. Well, let me use a different color. Let's use this color. So we have 11 total. All right. Then we're going to identify the number of repeating letters. So be careful now. We're looking. So how many M's do we have? We just have one, so we don't have to write that one. But how many I's? 1, 2, 3, 4. We have 4 I's. 4 I's. Okay, how many S's? So 4 S's. And then P's, we got 2 P's. And that's it, right? Okay. So we've identified the total number of repeating letters. Okay, so here we are with our structure now. So what we're going to do is we're going to have total number factorial divided by repeating numbers factorial. Okay, so here we are plugging it in. Our total number is 11. So 11 factorial divided by, and you're going to multiply by each number. So we have 4 factorial times 4 factorial times 2 factorial. This is going to tell us how many ways, right? How many ways we can form unique arrangements. And let's look at how it looks in the calculator. In our calculator, remember we have a fraction. If we're going to put this whole thing in, remember we have these 3 things on the bottom of our, in our denominators. We need to hold them down there. We need to tell the calculator that's what we want to do. So we have 11 factorial divided by, and I'm going to put parentheses here because I need to hold those 3 things down at the bottom. I need to tell the calculator that I'm not just dividing 11 factorial by this 4 factorial, but I'm dividing 11 factorial by all 3 of these things down there, the multiplication of them. So parentheses, then I have 4 factorial times 4 factorial. Should look just like your problem. Times 2 factorial. And then close up your parentheses. Right. Now, push enter, and it should give you your correct response. So you get 34,650 ways. Did you get it? Okay, so we should have 34,650 ways. Okay. Let's try the next one. How many ways can we arrange the letters in characteristics to form unique arrangements? Again, count the number, total number of letters. So we have number 1. Okay, so number 1. Total number. And then number 2. Repeating numbers. Okay. So total number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, I got 15. Repeating numbers. Repeating, well, letters. I'm having much fun with this, as you can tell, right? There you go, letters. Okay. All right. Now I'm on track. So now let's get our repeating letters going on here. So our repeating letters, how many C's do we have? 1, 2, 3. So we have 3 C's. Then we have H, that's no, okay, 1 H. Then we have A's, 1, 2, so 2 A's. How many R's? 1, 2, 2 R's. And we have T's, 1, 2 T's. How many E's? Just 1 E. We got the R's. Oh, here's 2 I's. Let's see, we have 2 S's going on there. Gotta be very careful to make sure you're getting everything. All right, 2 S's. And I think we got everything. Okay. All right, so now we've got everything. Now let's go ahead and put it all together. So for every repeating letter, remember, we're going to multiply the factorial of them in the denominator. So here we go. So we have 15 factorial in our numerator divided by 3 factorial times 2 factorial times 2 factorial times 2 factorial times 2 factorial. 1, 2, 3, 4. 1, 2, 3, 4. I'm missing a 2. Times 2 factorial. Okay, it's a lot of 2's, isn't it? All right, so now we need to multiply all that together. Now, feel free to go ahead and do some of this in your head if you like. So remember, 2 factorial is 2 times 1. So this is really just saying 2. So 2 times 2 times 2 times 2 times 2. So 2, 5 times is 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Then 32 times 6 We can do that in our handheld calculator. So 32 times 6 is 192. So this is 15 factorial times divided by 196. So here we are. That way I don't have to do all those 2 factorials. That was a lot of factorials. It was easier for me to just do this part in my head and then do the easily calculations, get 196. So I get 15 factorial divided by 196. And we get this really, really big number. But now, is that right? Let's see. I think I might have did something wrong. So 2, 2, 3, 4, 5. Oh, I put 196 instead of 192, didn't I? This should be a 2. I read it wrong in my calculator and it said 2, but I put a 6. That can happen. This should have been a 2. Ah. So when I put it in my calculator again, that's going to give me the right answer now. So this should be 15 factorial. Watch out, it'll do it. I just did it, didn't I? Divided by 192. And there's my answer. It should be 681. 1. Okay, 080. 4,000. That's a lot of ways. All right. So you see how it works when you're trying to find the form, find how you can form unique arrangements by using the letters in a word. Okay. So now here we are, number 12. How many ways can you arrange the letters in cat to form a unique arrangement? Well, we have 3 letters in cat. So number 1, total number is only 3. But do we have any repeating? No. Is none. All right, so we don't have any. So that's just simply the numerator itself, which is 3 factorial. So my answer is going to be 3 factorial. What's 3 factorial? Just 6 ways. There's nothing to divide out there. All right, so that takes care of our uniqueness. Let's move on to filling in our table. You'll be able to do this. This comes our calculator work. So I'm going to leave this part of the video to you. You have your annotated notes here to fall back on. What you'll do, again, I'm going to show you just a couple of them, spot, to make sure you know where your, again, where everything is in your calculator. Again, please Google your calculator if you still have trouble finding it. Again, scientific calculators, most of these symbols are in your second function. Graphing calculator, because you see where they are in your math function. We're here doing combination. They're asking you to put it in. You'll see that your table has an integer column, a reduced fraction column, and a decimal. They want you to write all the places. Whatever comes out of your calculator, that's what they want you to write. So what you're going to do is, if you do have a whole number, an integer, then you're just going to write it here in your integer column. So all but the last three lead to your solutions, right? To your to integer solutions. So this column right here should all be your integers except for the last three columns. So all but your last three. All right. Okay, so put those in your calculator and your rows. So now what I'm going to do is, we've already worked combination, permutation, and factorial here. I'm going to come down . All right, I'm going to come down and I'm going to work 8 factorial divided by 4 factorial in the calculator. Again, here we have 8 factorial divided by 4 factorial. Push enter, and there's your answer. You should have 1680. When you get down here, your calculator, you'll see you have 100 factorial divided by 99 factorial. So you'll put in, let's see what the calculator says. So you have 100 factorial divided by 99 factorial. So I want to make sure I address something here, and then push enter. You see what your calculator says? Mine says error overflow. So your calculator will probably say overflow or error or something. It says calculations exceed the range of values this machine is able to display. Now sometimes it doesn't give you that detail of an explanation, but this is a program. So yours will just say error or overflow. What it is that your calculator only has so much memory and can only hold but so many numbers at one time. So this calculation is really, really large for your device. So it will come up like this. So sometimes you will have to do some simplification by hand to get your answer. And this will be one of those cases. So when you put it in your calculator and you get this message, that means that you may have to do some hand simplification. Here's what you're going to do. We see here that we have 100 factorial divided by 99 factorial. Now remembering what factorial means, we know that factorial means 100 times 99 times 98 times 97 and so forth and so on. And 99 factorial means 99 times 98 times 97 and so forth and so on. So since we know that, we're going to use that to help us. So our numerator expands out to be 100 times 99. Now look at it. Our numerator is 99 factorial. So I'm going to go ahead and stop here. Now, if you already know that that's what's happening, then you don't have to write it all out. So we know that we have this 100 factorial divided by 99 factorial is going to equal 100 times 99 times 98 times 97. I'm just going to take it out just a little bit. So 99 times 98 times, and then it goes on all the way out to 2 times 1. But then the bottom is 99 times 98 times, and then so forth and so on, all the way to 2 times 1. All right? Do we see that expansion now? Now, when we're simplifying, we remember we're multiplying. Here, this goes away. 99 goes with 99, 98, so forth, all the way out to 2 and 1. They all cancel, and you're only left with 100. You see that? So all of those big old numbers that your calculator couldn't hold, really it only reduces down to 100 is your answer. So our answer here, 100. Make sure you pay attention to what's happening. Just because your calculator doesn't give you an answer per se doesn't mean that there is not an answer. Sometimes you just have to do a little knowledge of simplification, knowledge of what you're talking about. Talking about factorials, you know how they expand out and expand it out, cancel what you can, and then whatever's left, do that in your calculator. I'm going to leave this next one up to you. Follow my process, all right, and follow the notes, a little more detailed outright, and see if you can get the answer for the second one. Then down here, again, you're calculating. Here we just did this, okay? Right here with these fractions, you can do some hand simplification if you like and simplify, or just use your calculator. All right, so if you're putting this in your calculator, 13 over 52 times 12 over 51 times 11 over 50. You're going to put it in just like that. So you have 13 divided by 52 times 12 divided by 51 times 11 divided by 50. Now, some calculators may not be this straightforward. They may require you to push enter for each one, or it may require you can use your parentheses functions. It just depends on your model of your calculator. Let's see what happens. When we put this in our calculator, we see we get this decimal. This is your decimal answer. This answer goes into this last column here. Everything that's in your calculator, that goes into this last column slot. Okay, so that would be right here at 0.0. I knew it was going to go away. 0, 1, 2, 9, 4. I could write that a whole lot better. All right, so we have 0.0 1294, 1294, and then you have 1176, 11765. All right, but now you have a decimal number. That means that you can write it as a reduced fraction. So remember that this column right here is your reduced fraction column. So if you get this funky decimal in your calculator, remember we did this in class where we were able to write our reduced fraction. Again, if you don't remember, you might have to Google it. But in the graphing calculator, you go to your math button. The first one is FRAC. It's already highlighted. Push enter twice. And it'll write it as a reduced fraction, which is 11 over 850. In your scientific calculator, remember you'll use your F to D button, all right, F to D button or S to D button. In some of your calculators, you have your toggle button. Remember, you have the two arrowheads pointing opposite of each other, right near your equal sign. So that's your toggle button to change from decimal to fraction again. So use that. Okay, almost done. Okay, and then here for your last one, again, using your combination. Again, here you have these two things inside of your numerator. Use your parentheses functions in your calculator to hold them together, and then divide all of that by this combination if you're trying to put it all in at the same time. If not, you do your pieces and then do your multiplication. I'm going to leave it up to you to work it out. And then you have your answers to check yourself to fill in your table. This is going to be really important on the test. Okay? All right. Now, let's go to this next slide. If I could figure out where I was. And I think I'm on page 67. All right. So on 67, I think we're going to stop at 14 here, where we're looking at probability. Okay, so probability is equal to the number of ways to get an event divided by the total number of ways. So probability is always a fraction. Probability of, again, the total number of ways is always your denominator. And then the number of ways to get the event they're asking you for is your numerator. Let's do some examples for number 14, and then we'll be done with this lesson. Suppose we are rolling a single fair die. So a single fair die, remember, we said that means 6 sides. So a single fair die, our sample size would be 1, 2, 3, 4, 5, 6. Okay? 6 possible outcomes. Find the following probabilities. Probabilities of what? Here is P of 4. So the probability of getting a 4 is what they're asking us. So probability of getting a 4. How many 4s do we have? We only have 1. So the probability of us getting a 4 would be 1 out of how many total ways you can get or roll the dice? 6. So 1 out of 6. Okay. Any questions? Hopefully not. Okay. Let's look at B. Probability of rolling an even number. How many even numbers do we have up there? 1, 2, 3 of them. So that would be 3 out of the total number, which would be 6. Remember to reduce your fractions. 3 out of 6, that equals 1/2, right? So 1/2. Does everybody see what we're doing? C. This would be a good time to pause the video. See if you can do C and D and then come back. All right. Probability of getting a 7. Probability of getting a 7. Do we have a 7 up there in our sample space? No. So that'd be 0 out of 6, which just equals 0. Cannot happen. This means cannot happen, right? Then probability of rolling an even or odd. Probability of rolling an even or an odd. Well, do we have even numbers? Yeah, 3 of them. We have odd numbers? Yeah, 3 of them. So that's a total of 6, right? So whether it's even or odd, that's all of them. So that's 6 out of 6, which equals 1. So 1, this means must happen. Okay? Note. Now pay attention now. I'm giving you some statistics here. So it says, note that parts C and D are the extremes for both, right? So you see that with C, we had where you couldn't pick a 7 because it didn't exist. So your answer came out to be 0. Then here for D, you had probability of choosing all of them. That's 100%. That came out to be 1. So those both extremes of the probability. So note. For parts C and D, are extremes for your probability. So that means 0 is less than or equal to the probability of the event happening is less than or equal to 1. So you have the extreme of it not happening to the extreme of it definitely happening. Then remember that the denominator is always 6 because it's of the sample size. So we use 6 always for our denominator because our sample size that we were talking about is this 6-sided die. So total number of ways, always the denominator, your total sample size. Your numerator is always the number of ways that that event can happen. Whatever they're asking you to find, that's your numerator. All right. So we've introduced our probability. We've talked about our factorial, our combination, our permutation. So go forward. I hope this video helps with some explanations. And of course, if you have any questions, you can always email them to me or come to the drop-in office hours. I've already posted them for us on Canvas and I've emailed them. So make sure you come and ask your questions or just email them. All right, talk to you later.